Before we dive into today's episode, make sure to hit that subscribe button. It's the best way to stay updated with our latest insights.
Ladies and gentlemen, welcome to the CTSS Academy podcast. The energy is electric. The crowd is alive. Let's dive into greatness. We're champions strong.
Before we start the show, don't forget to check our new ebook, Kill All Bugs, Learn Software Testing in One Day. For a limited time, it's only $9.99. Links in description.
Welcome back to the Deep Dive. Today we're talking about something really fundamental to your digital life. It's an identifier that's so core, it's usually set in stone before your device even leaves the factory.
That's right. You know, we always think about the things that change your IP address, your location. But behind all of that, there's this single, unique, sort of built-in serial number on every single thing you own that connects to a network.
And we are going deep on that exact identifier today. The Media Access Control Address. Most people just call it the MAC address. Think of it as your device's digital fingerprint.
Yeah, a fingerprint is a great way to put it. It's physically tagged right onto the hardware.
So our mission for this deep dive is to really unpack what this MAT address is, how its own structure tells you who made your device, and, how it's so different from an IP address.
And most importantly, we're going to get practical and show you how to actually find this thing and even change it on your own Windows machine.
Okay, so let's just jump right in. The full name is Media Access Control Address, and you said it's tied to the hardware.
Yes. Specifically, it's assigned to your Network Interface Controller, the NIC. That's the little chip that lets your computer talk to a network, whether it's Wi-Fi or a cable.
And because it's hardwired into that chip, that's why it's called the physical address.
Exactly. It's known universally as the physical address. It's supposed to be this permanent, static identity that just exists no matter where in the world you are.
So if my IP address is telling the internet, hey, I'm at this specific street corner right now.
The MSC address is saying, and I am this specific car. Doesn't matter what street you're on, that's why it's so important for local network security.
Okay. So when I connect to the Wi-Fi at a coffee shop, the router there doesn't really care about my big public IP address at first?
Not at all. The first thing it needs to know is the MAC address of your specific laptop. Right there in the room so it knows who to send data to and who's asking for it. It sorts out the local traffic.
Got it. So what does one of these addresses look like?
Well, technically speaking, it's a 48-bit address. You sometimes see 64-bit now, but 48 is the standard. And it's almost always shown in hexadecimal format.
So like 6 pairs of numbers and letters separated by colons or hyphens?
Yep, that's the one. And in the grand scheme of networking, in that OSI model we hear about, it operates really low down.
That's okay. Where does it fit?
It's right at the link layer. That's the layer that's all about direct device-to-device communication. It's the conversation between your computer and the router that's literally feet away from you.
So the link layer is kind of like a local party line. All the devices are in the same room, and the MAC address is just the tag to make sure a message gets from my phone to the router and not to the person's laptop next to me.
That's a perfect analogy. It manages the neighborhood traffic before a single packet gets sent out to the big wide internet.
Now, you mentioned its structure is really revealing. It's not just a random string of characters, is it?
No, not at all. It's highly structured. That 48-bit address is broken into 6 octets, or 6 groups of 8 bits. But the really interesting part is how it's split right down the middle.
A split. So the first half tells one story and the second half tells another.
Precisely. The first 3 octets, the first 24 bits, form something called the Organizationally Unique Identifier, or OUI.
The OUI. And that tells you what?
It tells you who made the hardware. That number is globally registered with the IEE. So just by looking at those first 6 characters, you can tell if the network card in your device was made by Apple or Intel or Cisco.
Wow. So that's a truly fixed identity then. My IP address can change a dozen times a day, but that OUI is always going to point back to the company that built my phone.
It's a manufacturer's barcode, basically, etched right into the silicon.
Okay, so if the first half is the company ID, the second half, the last 3 octets, that must be what makes my device unique from all the other millions they made.
You got it. Those last 3 octets are the Network Interface Controller Specific Identifier. The manufacturer takes their global OUI And then for every single card they produce, they just assign a unique one-off serial number for that second half.
So it's a two-part key. A corporate identity paired with a unique device number.
It is. But, and this is where it gets really clever, certain bits within that structure are flagged to define how the address can be used.
Okay, instead of getting into the weeds with bit numbers, what do those flags, what concepts do they represent?
Right. They basically determine two things, usage and scope. For usage, a bit can flag the address as unicast, meaning the data is going to one single device.
And the other option?
Is multicast, which means the address is for a group, like a data stream that multiple devices might be listening to.
Okay, and you also said scope. This sounds like it gets to that idea of a fixed identity versus a flexible one.
It does. A bit in the scope section tells the network if this address is globally unique, meaning it's using that manufacturer's OUI and it's one of a kind of the world, or if it is locally administered. And that right there, that's the built-in escape hatch. It's a little flag that tells the network, hey, ignore the factory settings. This MHE address has been set manually by an administrator.
Ah, so that distinction leads us right into the different types of MVS addresses. The default one is what, the global one?
Yep. The default is the universally administered address, or UAA. That's the one we've been talking about, the one assigned at the factory with the official OUI. It's your device's birth certificate.
But the moment we flip that locally administered bit, we're talking about something else entirely. We're talking about implementing a locally administered address, or LAA.
And the LAA is a custom address that completely overrides the UAA. A network admin, or even you, can manually assign an LAA to a device.
And the really critical point here is that an LAA does not contain the OUI, right?
Correct. You are completely ditching the manufacturer's identity and creating a totally new, localized fingerprint for your device just for that network.
So why would you do that? What's the use case?
Well, for an IT admin, it's huge. Say a server's network card fails. They can pop in a new one and just assign it the LAA of the old card. Instantly, the new hardware has all the same permissions and firewall rules. No need to reconfigure the whole network.
That makes sense. A huge time saver. But for an individual user, it's probably more about privacy, isn't it?
It often is, yeah. If you connect to a public Wi-Fi that tracks devices by their MAC address, maybe for ads, or to limit your time changing your MAC with an LAA, makes you look like a brand new device every time.
So it disrupts that kind of tracking, but you're not actually changing the hardware, are you? The original UAA is still there somewhere.
It is. The original is still burned into the NIC. The operating system just agrees to present the new LAA identity to the network instead.
Okay, so let's really nail down the comparison with the IP address. We've touched on it, but let's lay it out clearly.
Let's do it. So full forms, MAC is media access control. IP is Internet Protocol.
And the big one, the reference. MAC is the physical address burned into the hardware. IP is the logical address assigned by the network.
Right. The MC is the car's VIN number. The IP is the license plate, which can change every time you cross a state line.
What about size?
MAC is 48-bit, generally. An IPv4 address is 32-bit.
And the OSI layers we talked about? MAC is for the local chat on the link layer.
And IP is for the long-distance routing on the network layer. You need both of them working together.
How about how a network finds them?
To find a MAC address on a local network, a device sends out an ARP request. That's the Address Resolution Protocol. To find an IP, it's often RARP, the reverse protocol.
And finally, structure. MAC addresses are all one type.
Right, they're uniform.
Yeah.
But IPv4 addresses have those classes, class A, B, C, and so on, to manage different sizes of networks. They really are two different tools for two different jobs.
The MAC gets the data from your computer to the router. The IP gets it from the router to, well, anywhere in the world.
You've got it.
Okay, let's get practical. For anyone listening right now who wants to see this for themselves on a Windows machine, how do you find your physical address?
The quickest, most reliable way is the command prompt. Just open it up and type ipconfig all. One command.
And it just dumps a ton of information. You're looking for the line that says physical address, right?
That's the one. You might have a few of them listed. One for your Wi-Fi, one for your Ethernet cable, so you just find the one you're currently using.
And if someone isn't comfortable with the command line, is there a clickable way?
There is. You can search for View Network Status and Tasks in your settings. From there, you just click on your connection, then hit the Details button. The physical address is listed right there.
Perfect. So that's how you find the UAA, the factory setting. Now, how do we use that LAA option? How do we actually change the MAC address in Windows?
The most common method is through the device manager. You navigate to it, expand the network adapters list, and then you right-click on the adapter you want to change.
And then go into its properties.
Yep, go to Properties and then click on the Advanced tab. In that list of properties, you're looking for one called Network Address, or sometimes Locally Administered Address.
Okay, and once you find that, you just type in the new one.
You select the little value button next to it, and then you type in your new 12-digit MAC address. Really important. No colons or hyphens, just the numbers and letters straight.
And then what? Is that it?
Not quite. You have to restart your computer. That's a mandatory step for the change to take effect. Afterwards, you can run ipconfig all again just to confirm it worked.
Now, what if that option isn't there? I've heard sometimes it's locked down.
It can be. For power users, the other method is using the registry editor. You open Regedit and navigate through a pretty long path in the system registry to find your specific network adapter.
That sounds a bit more involved.
It is. You have to find the right folder, manually create a new string value, name it network address, and then enter the new MAC value there. And again, you must restart your PC to apply the change.
So, two paths to the same goal. Implementing a locally administered address and taking control of what your device's physical identity looks like to the local network. Okay, so let's wrap up this deep dive. The MAC address is this unique 48-bit physical identifier. It is absolutely essential for managing local traffic.
And its architecture is a dead giveaway. The first half, the OUI, identifies the manufacturer and establishes this globally fixed identity.
But as the sources show, there's a built-in override switch. That locally administered address, the LAA, lets you or an admin completely sidestep the manufacturer's ID and create your own.
Which leaves us with this really interesting tension. You have an identifier that is designed from the ground up to be static, to be universally traceable back to a company.
And yet it has this built-in mechanism that allows for, localized flexibility, for a kind of anonymity even.
And this raises a final thought for you to consider.
Right.
We know your device has this permanent, indelible identity, but you also have the power to put a mask on it. In a world where we are tracked more and more by these fixed identifiers for security, for advertising, for data collection, the ability to control your device's so-called physical address is an incredibly powerful tool.
So the question is, what identity are you choosing to show the network? And when is it important to make sure that identity is local and not universal? Something to think about the next time you connect to a new network.
Thanks for listening. If you found value in today's episode, please subscribe and leave us a review. It helps more people find the show. See you in the next one.
Hey, yo, haven't you checked out our new book yet? Link in description.